Hey guys, I hope you're having a good week. So it is Tuesday, January 9th. You should be taking notes on this on, again, Tuesday, January 9th. If you're not on Tuesday, January 9th, you might be a little bit behind in your notes or you're going ahead. So go back and look and see where you're at. Our target today is that we are going to be able to describe the graphs of equations in the form of y equals mx. And last year you didn't talk about it with mx. You talked about it kx. So sometimes you'll see this as or y equals kx. Okay, we're going to go over what this k/m is. So let's go ahead and get started. Alright, our vocabulary terms for today are proportional, direct variation, and constant of proportionality. Proportional, remember, means corresponding. Let's say 1/2 corresponds with 2/4. They're equivalent, they're proportional, okay? 1 times 2 is 2, 2 times 2 is 4. Proportional. Alright? A direct variation is what we call this proportional graph. That's what we're talking about. We're talking about this proportional graph. We always write it in these forms. They're always going to come out with I call these our skeleton forms. And we're going to say y equals mx or y equals kx. Specifically this year we're going to use mx. M stands for this constant of proportionality, m or k. Constant of proportionality. And last year you learned that the constant of proportionality was the unit rate without units. That's what constant of proportionality is. So if you can find out where x is 1, this is where you're going to find your unit rate. Alright, and this is going to be called your constant of proportionality, and that's what you're going to plug in for m. Don't stress out yet. Okay, we're going to do practice. We're going to practice, okay? But I want you to notice we're specifically going to be looking at graphs today, not necessarily the equation yet. I'm just getting you ready, okay? Alright, here we go. Again, don't stress, we're looking at graphs today. Alright. The cost y in dollars, example 1, to rent X video games is represented by the equation. Given the equation, graph them. To graph, I need you guys to, 1, go from the equation. So you need to find the equation. Sometimes you'll have to make it. 2, make a table. And then 3, then you can graph. Here's the process that we are going through to graph these y equals mx problems. Our equation is y equals 4x. We're going to make our table. Remember, it's been a few weeks. I talked about how I liked tables to start with these ones. If you're not given anything, go with these ones. -1, 0, 1, 2. Okay? So we're going to plug that in. -1 times 4 is -4. I would pull out a calculator at this point. In case, if you're struggling, you don't worry about the multiplication. Let your calculator do it right now. Okay, now we're going to plug in 0. 0 times 4. 0. 1 times 4. 4. 2 times 4. 8. Okay, so we have our equation. We made a table. Now we're going to graph it. Here's our order pairs. Remember, x tells us to go right or left. Y tells us to go up or down. So left 1, down 4. 0, 0. Right 1, up 4. write 2 up 8. And that one came off my graph a little bit, so I'm not going to stress about that one. Now, the last thing that we have to do is connect dots with arrows. So, what I mean by that is there needs to be arrows on the end of your line. This should be making lines, okay? We're making lines. And it's super important that you're using a straight edge. Make sure you grab that ruler, grab that piece of paper, remember my rulers are up at the countertop. I have lots of rulers for you guys for this reason. Make it a straight line. Don't just put any type of line on there. So that's why I grabbed my straight edge. Okay, so I'm going to make my line going this way first. And then make my line going this way first. And this should, again, be making a straight line. And here's what I mean by arrows. Add the arrows at the end because this continues. These are important to have. And you did it. That's all you got to do. All right. Example 2. A daily wage Y in dollars of a factory worker is proportional to the number of parts X assembled in a day. A worker who assembles 250 parts in a day earns $75. Write the equation. So this one, the equation wasn't given to you. Okay. The daily wage Y is proportional to the number of hours. Good. A worker who assembles 250 parts in a day earns $75. 250 parts. So, I don't know how much they make So I need to figure out how much they make, because X stands for, number of parts assembled. I don't know how many number of parts they assemble in a day, but I do know, no I don't. Yeah, it says a day right here. Oh, great. So now we can make our equation. Go back, rewind. So a worker who assembles 250 parts in a day earns $75. So the daily wages, Y equals, he assembles 250 parts and he gets $75. Okay. So, how are we going to write our equation? Last year you learned about going from input to output by this K, this constant of proportionality, and that's what we're looking for. So we find this K by doing 75 divided by 250. What times 250 is 75, because that's that rate he's being paid, okay? Alright, and we find out that 75 divided by 250, remember, first number goes in the calculator, divided by second number in calculator is 0.3, okay? This is what we needed to know. What times 250 is 7.5? Sorry, what times 250 is 75? 250 times 0.3 is 75. So 0.3 x. That fills in that skeleton equation of y equals kx. And you did it. Now, we're going to predict off of our equation, okay? How much does the worker earn who assembles 300 parts, okay, in a day? So, y equals 0.3 times 300, because remember parts is x, which equals 300 times 0.3 is 90. So a worker who assembles 300 parts makes $90 in a day. So they're getting 30% in money, 30% of the money of how many parts they make. All right. Example 3. At a track event, the distance y in meters traveled by a student A is x seconds, represented by this equation. The graph shows the distance traveled by student B. Awesome, awesome. Which student is faster? So let's go ahead and graph this student next to student B so we can see -1, 0, 1, 2. They can't go negative distance, so I'm going to ignore that -1 right now. 0 times 7 is 0. 1 times 7 is 7. 2 times 7 is 14. Alright, let's go ahead and put that one on there. Alright, 0, 0. 1, 7. Ooh, they're slightly under. 2, 14. So here's student A, and here's student B. Which one is faster? Student B. Graph the equation that represents student A in the same coordinate plane. Blue. Compare steepness of the graphs. What does this mean in the context of this problem? Who has the steeper? Okay, student B has the steeper line, and it means he's going faster. Awesome. We are getting to the on your own portion of this. Okay. I will help you out with the equation parts right now, and then I need you to compare them. All right, a maple tree grows at 1.5 per year. So this maple tree is y equals 1.5 per year x. Okay. We're looking for this rate of change from here to here. All right. And it looks like we're just multiplying by 12. 1 times 12 is 12. 2 times 12 is 24. So this second tree, a pine tree, is y equals 12x. Alright, I need you to graph them and say which one grows faster. We wrote the equations, then you're going to graph them, and now I need you to compare the steepness. Alright, here's what we should have gotten when we graphed them. That maple tree was steeper than that pine tree, so the maple tree grows faster. Go ahead and what do we notice about proportional graphs? I want you to do your best remembrance of last year. Do your best guess, because tomorrow, when you come back tomorrow for notes, I will plainly state what the characteristics of proportional graphs have. Okay, so you can go back and check this. Alright, your checkpoint is up and ready for you to go. Go do your checkpoint. Your homework is a worksheet that you guys started yesterday, so make sure you keep that packet where you were doing 4.3 problems, the activities. Okay, the homework is on that page. I hope you guys are having a good day. Email me if you have any questions. Alright, bye guys.